Hello everyone, this is Sahiti on behalf of Edureka and I welcome you to this session on Kubernetes Networking. So thank you all the attendees for joining in today's session. Before we get started, all of you just give me a quick confirmation on the chat window whether I'm audible or not. Okay, I've got many yeses. Alright, so that's great. So now without wasting any further time, let me tell you the topics for today's session. So we'll start today's session by understanding what exactly is Kubernetes, and then I'll brief you about Kubernetes Cluster. After you understand the basics of Kubernetes, I'll tell you about Kubernetes networking, in which I'll talk about the pod-to-pod communication services and Ingress networks, and then I'll introduce you to the network plugins that are generally used in Kubernetes. After discussing the theory part about Kubernetes networking, I'll show you a real-life case study on how a company got benefited because of using Kubernetes networking, and then I'll finally end this session with the hands-on part. So is the agenda clear to everyone? Okay, so that's great. So now let's get started with the first topic for today's session, that is, what is Kubernetes? Well, Kubernetes is a portable and an extensible open source platform for managing all the containerized workloads and services that not only facilitate configurations but also facilitate automations. It has large, rapidly growing ecosystems and supports tools widely available. So we can define Kubernetes as a container-centric management environment which orchestrates computing, networking, and storage infrastructure on the behalf of user workloads. This not only provides the simplicity for platform as service with flexibility of infrastructure as service, but also enables portability across infrastructure providers. Now, multinational companies such as SAP, OpenAI, SoundCloud, Pokemon, Box, eBay, the New York Times, and many more use Kubernetes. Now, how do you think these companies benefit with Kubernetes? Well, they benefit because of many features Kubernetes offers, such as it can be thought of a container platform or a microservice platform or any portable cloud platform. Now, anybody working with Kubernetes must also have an understanding of Kubernetes Cluster, as that gives the basics for networking. So let me tell you what exactly Kubernetes Cluster is. Now, the basic fundamental behind Kubernetes is that we can enforce what's called a desired state management, and really what that means is that I'm going to feed a cluster service in a specific configuration, and then it will be up to the cluster services to go out and run that configuration in my infrastructure, right? So one of the main components of the Kubernetes clusters is the API that sits in front of all of these services. So this is like the building block of a system, and the second building block of a system is a worker. So what is a worker? Well, a worker is just like a container host. So one unique thing about the worker or a container host in Kubernetes environment is that it does have a kubelet process, and that is responsible for communicating with the Kubernetes cluster services, and this whole setup with the workers and APIs and the pods is known as Kubernetes cluster. Now, let me explain you with an example here. So you can see this deployment file, right? So this deployment file has all the configuration that is required to feed into the cluster services. So it has pods, it has replicas, each pod has various container images which are going to be fed to the cluster services, and then it will be up to the cluster services to divide the pod and replicas into the worker nodes. So in this example over here, we have two pods, with the first pod having two container images and three replicas, and the second pod having only one container image and two replicas. Now, once this configuration is fed to the Kubernetes cluster services, it will be up to the cluster services to schedule these pods and the workers. So as you can see over here, the worker 1 has pod 1 replica 1 and pod 2 replica 2. The worker 2 has only one pod with one replica, and the third worker again has two pods with two replicas. So this can depend on the cluster services completely. Now, the main aim of cluster services is to make sure that the configuration is running across all of the containers or the workers. Now, you must be knowing about Docker, right? When Docker was there, why did Kubernetes come up? Because this has an approach of networking in a different way. So there are mainly four distinct networking problems to solve with Kubernetes that we have to deal with. The first one is the container-to-container communication. The second one is the pod-to-pod communication. The third one is pod-to-service communication. And the fourth one is external-to-service communication. So don't worry guys, I'll discuss each one of these communications in this session. So let me brief you about each one of them one by one. Now, container to container communication is basically the communication between two container images. The pod to pod communication is the communication between two different pods having various images and the replicas. The pod to service communication is how a service enables a pod to communicate with any other pod. And external to service communication is how an external to service communication is how something out of the cluster can communicate something which is inside the cluster. Now, before I get into the depth of all these, let me tell you the fundamental requirements of any network implementation in Kubernetes. So, all the containers can communicate with containers without NAT. All the nodes can communicate with all the containers without NAT, and it's also vice versa. Not only this, but the IP that the container sees itself is the same IP that others see. So, these are some fundamental requirements that you need to understand before you start with Kubernetes networking. So now, as I was talking so much about Kubernetes networking, let me tell you what Kubernetes networking is all about. So Kubernetes networking mainly deals with the communications between pods, services, and external services to the one in clusters. So it's all about communications. So for your better understanding, I've divided the networking concepts into containers and pods, services, and ingress networks. So first, let's start with containers and pods. Now, what do you think pods are? Well, pods are nothing but the basic units of Kubernetes applications that are built from. So a pod consists of one or more containers that are allocated on the same host and are configured to share a same network stack or other resources as volumes. In simple terms, we can just say that the containers in a pod can reach each other on the local host. So for example, if a pod has 5 container images, all the container images can interact with each other on the local host. Now let's consider an example here. So starting from the top, we have a physical network and a Docker bridge connected to it. So attached to that, we have two containers, one working at virtual Ethernet 0 and the other one working at virtual Ethernet 1. Now both these containers are on the same logical network as the bridge. And both the containers can communicate the bridge as long as they can discover the other container's IP address somehow. But this doesn't get the concept of shared network pod. So since namespaces are very flexible, Docker can start a container and rather than creating a new virtual interface for it, it shares the existing interface. So both the containers have the same virtual interface and both are addressable and can hit ports opened by the other in the local host. So that's how two containers communicate between each other. But this can cause one problem. The problem is that this set of processes can take full advantage of decoupling and isolation of services while at the same time collaborating the simplest possible networking environment. So to implement this, Kubernetes implements this pattern by creating a special container for each pod whose only purpose is to provide a network interface for the other containers. So when you use the pause command, it suspends the current process until a signal is required. So it's basically like the heart of the pod providing all the virtual network interfaces that all the containers will communicate to use with each other and outside the world. Now you must have understood how two containers communicate with each other. But how will two different pods communicate with each other? So will two pods communicate with each other with the intranode network or the internode network? Now, before I talk about the two types of communication within the pods, let me introduce you to the components of pod network. So on every Kubernetes node, there is a root network namespace, a pod network namespace, and a Linux network bridge. Now, each pod has its own network with a virtual Ethernet pair connecting it to the root network. So this is basically like a pipe pair with one end in the root network and the other end in the pod network. Now this is done for all the pods on the node, and to enable pods to talk with each other, the Linux Ethernet bridge is used. So now that you have understood the pod network components, let me start with the two types of communication and let me start with intranode pod network. So intranode pod network is basically the communication between two different pods on the same node. So suppose we have two pods over here, pod 1 network and the pod 2 network, who have their own root network with the virtual Ethernet pair, right? So suppose just assume that a packet is going from pod 1 to pod 2. The packet leaves pod 1 network at Ethernet 0 and enters the root network at virtual Ethernet 0. Then it is passed on to the Linux bridge, which discovers the destination by using an ARP request, and then it finds out that the destination is on pod 2. So the virtual Ethernet 1 says that it has the destination IP, and the bridge now knows where to forward the packet. So once the bridge knows where to forward the packet reaches the virtual Ethernet 1 and crosses the pipe pair and reaches the pod 2 network. So that's how two pods communicate within each other on the same node. They just have to pass through the Linux bridge to know where is the destination IP, and then automatically the virtual Ethernet, which has the destination IP, takes the packet and forwards it to the pod network. So guys, that's how two pods communicate on the same node. Now, if you have two pods on two different nodes, how will they communicate with each other? So this is enabled by routing, and this is also known as the internode pod network. So as we all know that every node is assigned a unique CIDR block for the pod IPs, each pod has its unique IP and that does not conflict with the pods on the other node. So as the same way that the cloud provider routes tables and makes sure that the packet reached a correct destination, the same thing can be accomplished here by using the network plugins. So over here we have two different nodes having their own virtual Ethernet pairs, network interfaces and Linux bridge. Now we want two pods to communicate which are present on two different nodes. So suppose we want the packet to be transferred from pod 1 to pod 4. How is that possible? So let me show you how that's possible. So the packet leaves from the pod 1 network and enters the root network of node 1 at virtual Ethernet 0. Then it is passed on to the Linux bridge, which makes the ARP request to find the destination. After the Linux bridge finds out the destination, then the packet leaves the Linux bridge to the main network interface at Ethernet 0, since it finds out that nobody on this network have the destination IP address. So it leaves the machine node 1 and it enters the routing table to find out its destination. So the routing table has a route setup for each of the node CIDR blocks, and it routes the packet to the node whose CIDR block contains the pod 4 IP. So now the packet comes to know that its destination is on node 2. So with this, the packet arrives at the node 2 at the main network interface at Ethernet 0. Now, even though the pod 4 is in the IP of Ethernet 0, the packet is still forwarded to the Linux bridge since the nodes are configured with the IP forwarding enabled. So the node's routing table is looked upon for any routes matching to the pod 4 IP, and then the Linux bridge finds out that the destination for this node is at CIDR block. So the bridge takes the packet and makes the ARP request, and then it finally finds out that the IP belongs to virtual Ethernet 1. So virtual Ethernet 1 takes the packet, and finally the packet crosses the pipe pair and reaches the pod 4 network. So that's how guys two pods on two different nodes communicate. They are just helped with the routing table, which helps them to find out the destination IP which is present on any different node, right? So that was all about container to container communication and pod to pod communication. Now, let's move on and talk about the second topic, that is services. Now, how do you think these services help in the communication of pods? So when clients connect to the proxy and the proxy is responsible for maintaining a list of healthy servers to forward its requests, there are few requirements to the proxy. It must be self-durable and resistant to failure. It must have a list of servers that it can forward to, and it must also have some way of knowing if a particular server is healthy and able to respond to requests. So the Kubernetes designers solved this problem in an elegant way by building all the basic capabilities of a platform to deliver all of these three requirements, and then they developed a resource type known as service. So we can define service as a type of Kubernetes resource that causes a proxy to be configured to forward requests to the set of pods. The set of pods that will receive a traffic is determined by the selectors which match the labels assigned to the pods when they were created. Once the service is created, we can see that it has the assigned IP address and will accept the request on the port. Now, there are four types of services that you have to understand so that you understand the option for exposing a service onto the external IP address. The cluster IP, the node port, the load balancer, and the external name. Now, The cluster IP is the default service type, and by choosing this type of service, we expose the service on a cluster internal IP. So basically with this type of service, the service is only reachable within the cluster. After cluster IP, we have the node port. So this type of services exposes the node's IP at a static port that is nothing but the node port. A cluster IP service to which the node port service will route is automatically created, and you'll be able to contact the node port services even from outside the clusters. After the node port, we have load balancers. So the load balancer exposes the service externally by using a cloud provider's load balancer. Node port and cluster IP services to which the external load balancer will route are automatically created. And finally, we have the external name. So basically, this service will map the service to the contents of the external name field by returning a CNAME record with its value. There's no proxying of any kind in the setup, and it requires a 1.7 or a higher version of kubedns. So guys, these were the 4 types of services that you need to understand. So now that you've understood the pod-to-pod communication, the container-to-container communication, and the services-to-pod communication, let's deep dive into the external-to-service communication. And this comes with none other than the Ingress network. So Ingress network is a collection of rules that allow inbound connections which can be configured to give services externally through reachable URLs, load balanced traffic, or by offering name-based virtual hostings. So Ingress is the most powerful way of exposing services. The services and pods have IPs only routable within the clusters. It acts like an entry point to the Kubernetes cluster. Ingress is also an API object that manages the external access to the services in a cluster with the HTTP request. And then, finally, it also sits in front of the multiple services and acts as a smart router, right? So now that I've told you about Ingress networks, let me tell you how does it work. So over here, let me explain you with an example. So we have 2 nodes having the pod and the root network namespaces with a Linux bridge. In addition to this, we also have the virtual Ethernet device called the Flannel 0, which is a network plugin. Now what the network plugin does is that it basically helps to route the packet to the desired destination. So over here, we want to route the packet from pod 1 to pod 4, which are on 2 different nodes. So the packet leaves pod 1 network at Ethernet 0 and enters the root network at the virtual Ethernet 0. Then it is passed on to the Linux bridge, which makes the ARP request to find the destination, and then when it sends the ARP request, it finds out that nobody on this pod has the destination IP address. So the Linux bridge sends the packet to the Flannel 0 as the node's routing table is configured with Flannel 0 for IP forwarding. Now, the Flannel daemon talks to the API server of Kubernetes to know all the pod IPs and their respective nodes to create mappings to the node IPs. The network plugin then wraps this packet in a UDP packet with extra headers changing the source and the destination IPs to their respective nodes, and then it sends the packet out via Ethernet 0. Now, since the routing table already knows how to route the traffic between the nodes, it sends the packet to the destination node 2, and then the packet arrives at Ethernet 0 of node 2 and goes back to the Flannel 0 to decapsulate and emit it back into the root network namespace. So the packet is again forwarded to the Linux bridge by making an ARP request to find out the IP that belongs to the virtual Ethernet 1, and finally the packet crosses the root network and reaches the destination port 4. So guys, that's how external services are connected with the help of Ingress network. So as I was talking about network plugins, let me introduce you to the top network plugins available in the market. So we have the Google Compute Engine, OpenContrail, Cilium, Project Calio, Flannel, Amazon Web Services, Romana, Weaveworks, OpenWeaveSwitch, and many others. So these are just few. We have many more in the list that you can refer from the Kubernetes official documents, right? So guys, that was all about the theory part of Kubernetes networking. Now, let me show you a real-life case study about Kubernetes networking and how a company benefited by using Kubernetes. So Wealth Wizards is an online financial planning platform that combines the financial planning and smart software technologies to deliver expert advices at an affordable cost. Now, It was extremely important for the company to quickly discover and eliminate code vulnerabilities with full visibility of their cloud environment, but they also wanted to control the traffic through access restrictions. So, they used Kubernetes infrastructure to manage the provisioning and rollout of clusters with the help of tools to manage the deployment and configuration of microservices across the kube clusters. They also used network policy features of Kubernetes to allow them to control traffic across restrictions. Now, the problem was these policies are application oriented and can only evolve with applications, but there was no component to enforce these policies. So, the only solution the company could find out for this was to use a network plugin, and hence they started using the network plugin ViewNet. So, the network plugin created a virtual network that has a network policy controller manager to manage and enforce the rules in Kubernetes. Not only this, but it also connected the Docker containers across multiple hosts and enabled their automatic discovery. So suppose you had a workload in the cluster and you wanted to stop any other workload in the cluster talking to it. You can achieve this by creating a network policy, and that restricts the access and only allows ingress to it via the ingress controller on a specific port. Now, with this deployment on each Kubernetes node, the plugin manages the interpod routing and has access to manipulate the IP tables. In simple terms, you can just understand that each policy is converted to a collection of IP table routes coordinated and configured across each machine to translate the Kubernetes tags. So guys, that was how Wealth Wizards benefited by using Kubernetes Network with the help of network plugins. Now, as I was talking so much about network plugins, let me show you practically how it is done. So we're going to deploy a multi-tier application over Kubernetes networks which are present on two different pods and have a container image. So suppose you want to store the product name and product ID. So you'll need a web application and a database. So those are the two applications that we're going to use, and each of these applications will have their own container images and pods. And then we're going to form a communication line between them with the help of services. So let's get started with the hands-on part. So the first step is to make a working directory for your project. So we'll make a working directory. So let me type in the command mkdir, and let's say I create a directory saying demo, and then I'll change my working directory to that directory. So I'll type in demo. So we are in a working directory. Now you have to create a deployment YAML file for both of your applications. So to create that, you just have to open a new file and then mention the specifications required. So let me create the file. Let's create a deployment file for the web application first. Let me open a file. Alright. So I've created my deployment file for the web application. So we have the API version, basically defining the API version for it. Then in the metadata, I've given my deployment name as web app 1 with the labels for web app SQL, tied to be front end because this is the front end application, and then we are mentioning the specifications for the containers and also for the port. So in the same way you have to create for the MySQL application. So let me again open a new file. Alright, so I've created my deployment file for the MySQL application. So again, the API version is defining our API version and the kind to be deployments because it's a deployment file. And then we are giving the name for this deployment file to be SQL database and the tier to be backend since it is a backend application. And then we'll also mention the specifications for the containers. So in the specifications of the containers, we are mentioning the port where we want it to run and also the image from where we are pulling it. So once all this is mentioned, you just have to close your application file. And then you'll have to check for your deployment. So for that, you have to type in the command kubectl apply -f and the name of your deployment. So over here, I have my deployment files. So you can see that our first deployment has been created with the command kubectl apply -f and the name of the deployment file. So similarly, you have to do it for the MySQL application. So you just have to again type in the command kubectl apply -f and the name of file, right? So you can see that both the deployments have been created. Now, if you want to check if your deployments have been created or not, so you just have to type in the command kubectl get deployment. So you can see that both your deployments have been created with their respective names that we had given them. Now, what you have to do is you have to create services. So to create services, you again have to open a file and then mention the specifications required. So let's open a file. So let's say, suppose I open a file, web service. So we have mentioned the API version to be v1, which we had mentioned in the deployment file. The kind to be service because it's a service that we are creating, the name of the service, and then the app name, and the tier to be front end because we're creating the service for the front end applications, and the port. So the type of service that we're choosing is the node port. So I'll save this file and then I'll close this. Similarly, I'll do it for the MySQL service. Let me create a new file, MySQL service, and mention the specifications. Alright, so again, we have mentioned the API version to be v1, the type to be service, because with service that we're creating, the name, the type to be backend, because it's a backend application that we're dealing with, the port, and the type of service is cluster IP. So once it is done, I'll save this file and then I'll close this. Once your services are created, you have to again deploy your services. So for that, you'll use in the command kubectl apply -f and the name of the services, right? So I'll type in the name of the service and you can see that the web service has been created. Similarly, we'll create for the MySQL service. So I'll again mention the command kubectl apply -f and the name of that file. So that's MySQL service. Now, once both of your services are created, just to check if your services are done or not, you just type in the command kubectl get services. So you can see that apart from your Kubernetes cluster service, you also have the web app service and the SQL services. So now you have to check the configuration of pods after you're done creating with the services. So for that, you'll type in the command kubectl get pods. So you can see that the web application and the SQL are running on two different pods and have their own container images. So now to create a communication line between the web app application and the database, you have to go inside each container image and you have to configure some stuff. So let's first go inside the web app container. So for that, I'll type in the command kubectl exec-it, the container ID of the web app application, and in the command with a bash. So once you're inside this container, what you have to do is you have to open the index.php file, which is basically the configuration file for your web app application. So for that, I'll type in the command nano and then I'll mention the directory. So once your configuration file has been opened up, you have to change the server name, password, and the database details that you want. So let's mention the server name to be web app SQL1 that we mentioned for the MySQL container. The password to be Edureka since it's my user ID password. The database name to be, let's say, product details. So once you're done mentioning all the details, you just have to save this file. Once you're done saving this file, come out of this container. So for that, type in the command exit and you'll be out of this container. So now once you're out of the web app container, you'll come inside the MySQL container. So for that, you'll type in the command kubectl exec-it, the container ID, and bash. Then you'll have to get the access to the MySQL container. So type in the command mysql-u root-p and your password. So now once you've got the access to the MySQL container, you have to create the database and the table that you mentioned in the web app containers configurations. So for that, you'll type in the command create database product details. And then you'll use the database. For that, you'll type in use product details. Then you'll create a table that you mentioned. So you'll type in the command create table products, product name, and varchar, let's say 10 characters, product ID, and let's say 15 characters. Once it is done, you can see that a table has been created. Now just exit this MySQL container and come out of it. Alright, so now once you're done with this, you'll check the port on which the services are working. So for that, you'll type in the command kubectl get services. Alright, so you have to open your web browser and then open the web application. So you can see that our web application has been opened up. Now let's input some values. So let's say I input headphones with some ID and then I'll submit query. So you can see that a new record has been created successfully. So let me type in some input so that I can show you in the database whether they are stored or not. So I've entered few products. So now let me go back to my MySQL container and let me use the database. Once the database is used, let me show you the tables inside it. So we just have one table, that is products. So we'll select all the tuples from products. So for that, I'll type in the command select staff from products. All right. So as you can see that we have got the output of all the products that we have given as input. So there was one product that I did not give an ID and rest all stored with the product name and the product ID. So guys, that's all for today's session. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!